I'm Kai Xin. I'm a data scientist at Lazada. That's my core job. I'm also the co-founder of Data Science SG, the biggest data science community in Singapore. There is for example, we are seeing what works is through games. Basically, make it interesting. I think the biggest issue with programming is it looks very scary. And you add a layer of data and numbers and formulas on top of it is even more scary. So I think taking away that scary factor and making it as intuitive as possible. So there is, for example, Sketch. There's a couple of other platforms that people can drag and drop objects into. For example, they can build games by dragging a bear into the scene and then make the bear walk down the road or something. Simple program. In fact, it's quite complicated back end. There's a lot of mathematics behind the dynamics and stuff. But they don't need to understand that. They need to see that they can create stuff easily. It's a bit fake in a sense, but easily enough that they have the confidence to investigate further. Okay, so now I want the bear to walk in a different direction. I want it to dance, and maybe the base model don't allow me to do that. How can I attack the code? How can I tweak the code such that it does what I want to do? So in the end, that's the whole mindset of a programmer. You start with something that you thought was interesting, and then you kind of extend the capabilities of the library, or extend the capabilities of the baseline, and you build more and more. You have a scene now, you have multiple objects, multiple people, multiple things interacting with each other. So it all starts with the confidence that you can do it. It's just doing it a bit more, and eventually when you look back, you have come a very long way. I think that's important, the confidence. That's why when we for example, when we do workshops and stuff, it's always make it such as simple as possible to even install. The most basic thing is people get stuck as, I can't even install the freaking thing, I can't even get the package to work, I can't even connect the basic stuff, I feel like an idiot. But no, you're not an idiot, it's just that it depends on the settings of the computer, depends on a lot of factors that's beyond your control. And when you take away that layer from people and make it as simple as possible, and then people will start learning, and then once they have the interest, you can't stop them. People just keep going. I think for most, again, school is not for everybody because it has a very specific kind of box that works. It works for people who want structured learning, and that's not a bad thing. So school is very good for structured learning and for, of course, credentials. At the end of the day, not everyone can be the co-founder of Uber or Apple. So a lot of the people will need a credential, and a computer science credential, computer engineering credential is a good credential to get you into the interview room. Having said that, I'm not a very structured person, so I'm not the best student. I'm a mediocre student. I learn on my own, in my own way, in my own speed. And I like to go deep in certain things. I like to just touch and go in certain things. So school is good to give you the foundation. So I studied at SMU, Singapore Management University, and they gave a foundation, teach me what are the things to look out for in my education, but I still figure out myself as I go into the industry. So to make it short and sweet, school works for a group of people, it works really well. For a group of people, it works not so well. But it still gives you a a quick overview of stuff that you can know where your weakness is. And most importantly, again, I think for me is it gives the friendship. Because programming is a very difficult thing at a higher level, you need the friendship, you need the support system, and school really provides you with the friends to wine and beach together, cry together, and complain about how difficult life is and stuff. And that's important because if you do it on your own, unless you're extremely passionate or extremely you really have a structure for yourself, you'll give up, definitely give up. So school provides that social thing. I think it's important. So I talk to a lot of young people, and I even interviewed quite a couple of them. The first thing they just come to interview and said, fresh out of school, I'm going to build a recommender for you. I'm going to make you millions of bucks. I'm the best. Now that is probably the opposite way of being a good data scientist or starting on one. I think foundation is important. I think it'll be good to spend a couple of years starting from the most basic thing of understanding how database work, how do you query a database properly, how to write good code. I mean,
those fancy algorithms or those fancy libraries come and go. Nowadays, the hype is all deep learning. Previously, probably they all boosted models and stuff. So the hype will change, and if you're just following the hype, you're just learning deep learning for the sake because everybody's talking about I'm gonna learn deep learning, I'm gonna like apply and change the world. That's great, but when the next wave come, you won't be prepared because your foundation is weak. You need to understand the mathematics behind it. You need to understand the why are we doing this. So there's a business part of it, and this takes time. So I guess the best answer I have for you is be patient. Start from basics. Be a good programmer first. You need to understand statistics and mathematics. So read up more. There's a lot of Coursera courses, Udemy, Udacity. There's a lot of free resources out there to help you. So join meetups, talk with people, understand what the business people does. Meetups are great because a lot of time, for example, at Data Science SG, we invite a lot of the speakers. Uber just came yesterday. A lot of companies come down to share what they actually do, what are their concerns, how they solve problems. So you need a problem-solving skill from the business side. You need the mathematics to understand the formulas. You need the programming to kind of bring it to life. You need all those components before you can really apply and kind of like be a contributing data scientist.